Okay, so this one is just what we already seen for chapter for analysis of variance. So actually we just only consider a single factor. Okay. So a single factor, for example, this one we have hardwood concentration, where we divide this one into hardwood concentration, which is we have 5, 10, 15, and 20. Okay. We have a single factor. For hardwood concentration is known as your level or your treatment. So for each concentration, okay, we have several observations. So this is your Yij. So in this case, we have equal number of your observations. So we have first observation, second, third, and also first the first observation for your first treatment, and then observation for your second treatment, and so on. Okay. Okay. When we model the analysis of variance, we have the model equation where we have Yij equals to mu I plus Eij. So your mu I is your mean for each treatment. Okay. So mu I you can write in terms of mu plus alpha I plus Eij. So Yij is your observation. Okay, mu is your overall mean, or we call this one as your grand mean. Alpha I is your treatment effect. Okay, Eij is your random error. So in this case, we assume that our Eij is normally distributed with mean 0 under the restriction summation alpha I is equals to 0. Okay. In this case, what we want to test is we want to test either about the treatment mean or treatment effect, the equality. Okay. Okay, this is the way how we write the assumption. Okay. So when we conduct the analysis of variance, we have total variability. So that one is called as sum of square of total variability. Okay. So this one is split into two groups where the first one is sum of square of treatment. So this one is variability between group. And then we have the other one, variability within group. So variability within group is your sum square error or sum square residual. It's the same thing, residual error, the same meaning. Okay. So this is the formula, and then we expand the formula. Okay, kita simplifikan. And then normally we will use this formula. We have double summation Yij square minus your grand total y dot dot square divided by capital N. So this is your total variety, total sum of square. Okay. And then we have the formula for sum square treatment. Okay, yi dot square over ni. Okay, minus the grand total square divided by capital N. And then the last value is your sum square error. Okay, again, you want to test either equality of the treatment mean ataupun you want to test for treatment effect. Either one, depends on the question. Okay. So this one is just under H0, when H0 is true, you have the expected value of mean square treatment is just sigma square. Let's say if your H0 is not true, so that's mean your H0 is false. The expected value, we have another term which is n summation alpha I square over k minus 1. So again, under H0, the term summation alpha I square is equal to 0. We give expected value of mean square treatment is again equals to some sigma square. Okay. So under H1, the term alpha I square is much larger than 0. So we have this one. So in order for us to compute the ratio of mean square treatment and mean square error, so if mean square treatment over mean square error is equals to 1, so this one will be approximately to 1. So that means 0.99 something, for example, when H0 is true. And this one, the value of your F ratio is greater than 1 when your H0 is false. So that means kita reject H0 lah. Reject H0, the punya value tu greater than 1. So we will like to reject H0 when the value of the ratio is much larger than 1. Okay. So since we have ratio of two variance, so that's why we use F distribution. So F distribution again, we have 2 degrees of freedom. Okay. So you build out once you compute your sum square treatment, sum square error, and also sum square total. You compute what is your F value. So first you need to have your degree of freedom. So treatment K minus 1, your error is N minus K, and the last one total it should be N minus 1. Then we compute mean square treatment, mean square error, and then you take your F ratio. Okay, reject H naught, we only consider when we have F calculated greater than F alpha. So you have the first degree of freedom is just K minus 1, and then the other one is N minus K. Okay, so this one is the way how you want to estimate the punya parameter, estimating parameters. Okay, so you have here is your mu head, is your grand mean. Mu I head is just Y I dot. Okay, the mean for the first treatment. Let's say if you want to find mu 2 head, so that's mean the mean for your second treatment. Okay, if you want to compute your alpha, so we just have this one. Okay, the mean for first treatment, for example, alpha 1. So that's mean the mean for first treatment minus your grand mean. Okay, kita akan follow lah kalau let's say if you want to estimate alpha 1, alpha 2, alpha 3, and also alpha 4. So again, we follow this formula. So we just replace this one by the mean for the third treatment or the mean for the second treatment and so on. Okay, then you get your estimate parameter for your alpha. Okay, kita ada 3 value lah maksudnya. That's mean you get your mu head. Okay, then you get your mu I head. In order for you to find your alpha I head, so use the formula yi dot, your grand mean, okay, minus your, mean for I treatment minus your grand mean. Okay, that is how we estimate the parameter. Okay. Okay, this one. Okay, we will try another exercise. Okay, we try to do this one, Okay. So again, this one, boleh nampak dia punya ni. So this one, you have 24 fresh graduates from a local university were randomly assigned to 3 groups to experiment with 3 different approach of learning English. Okay. So at the end of the semester, the English score of these fresh graduates were tabulated as follows. Okay. So we have the first approach, second, and also third approach. Okay. So the value is arranged in terms of column. Okay. So now how many numbers of your treatment? What is your K? What is the value of K in here? Depends on the question. What is the value of K? Okay, you have K is equals to 3. Okay, number of treatment ataupun number of level lah. Okay, we want to compare to the data above. Okay, provide enough evidence at 5% level of significance to reject the null hypothesis that the mean English score of all fresh graduate experience with each of these learning approach is the same. Okay, so now you have more than 2 population. So normally when we have more than 2 population, we will conduct analysis of variance. So when you refer to the question, you check. Okay, you check how many treatments. In this case, we have K equals to 3, which is more than 2. So we will proceed with analysis of variance. Okay. So now, what you need is to find, okay, let's say kita pakai, find the total for first treatment, total for second treatment, and total for the third treatment, and give me the grand total. Okay. And also compute Yij square. Okay, we need to find that one. Okay, cuba compute dulu. Okay. Let's say you already compute your Y1 dot total for the first treatment. Okay, let's say first treatment kita beta, and then you have, okay, first treatment, the total up. Okay, so this one you should get 588. Compare dengan saya punya jawapan. Okay, second one. You should get 576. And the third treatment, you should get 548. Okay, find the grand total. Grand total and then get the double summation Yij square. Okay, to compute double summation Yij square, you use shift sum, shift sum in your calculator. So you enter your data in your calculator and then press shift sum, find your summation x square tu. That will give you double summation Yij square. Nampak tak? Okay, y dot dot, your grand total should be, your total up, you should give you 1712, double summation Yij square. Squarekan dia punya value, kalau cara yang lama tu squarekan dia punya value, total up semua. Apa dia punya value dia? Dapat ke? Kalau dapat tulis dalam ini. Tulis dalam chat apa dia punya total double summation Yij square. Ada ni Hafiz. So you can actually kalau let's say double summation Yij square, cara yang sama yang saya ajar macam mana nak enter masuk data dalam calculator, you will use your mode SD in your calculator. Okay, cara yang paling cepat. So in your mode SD, once you already enter your data cara macam biasa yang kita buat itu. Lepas tu is depend on your brand of your calculator lah So kalau yang 570 ms, kita ada shift sum which is shift number 1 tu. Shift sum, dekat display tu it will displaykan summation x square, summation x and also n. So kat situ kamu boleh dapatkan double summation Yij square, sama je. Ada yang dah dapat? Double summation, selain daripada kira cara manually lah. Double summation Yij square. Boleh ke? Okay, 125084. Pakai mode SD ke kamu kira secara manual ni? Okay, good. Okay. Okay, so you will get 125084. Cuma kat sini, sebab bila kita nak kira tu, untuk yang total first treatment, second treatment and also third treatment tu, you have to total up macam biasalah. Sebab kalau tidak, dia tak kira, dia tak split kan Sebab bila kamu kira double summation Yij square tu, biasanya baru saya enterkan semua data in your calculator and then use lah shift sum tu. It will give you 125084. Okay, also y dot dot tu summation x tu. Okay, you will get 1712. Okay, so now write your hypothesis. What is your hypothesis null and what is your hypothesis alternative? Okay, kita nak compare three treatment. Okay, whether this one is the same or not. Okay, you write down your null hypothesis. So that's mean you want to compare your mean for example. Okay, lagipun soalan kita tadi, kita nak test whether the mean English score of all fresh graduate experience with each of this learning approach is the same. Okay, we sebut tadi mean So that's why we just write, let's say, first approach, mu B tadi tu. Okay, mu this one, and then mu delta. Okay, alternative. Okay, at least one of mu I is unequals to mu J. Okay, I is unequals to J, where your I, J is equals to beta delta. Okay. Okay. Yeah. So your alternative, at least one of mu I is unequals to mu J, or I is unequals to J, where your I, J2 is equals to your beta, your gamma, and then you have your delta visible. Okay. You want to test at alpha 0.05. So when you're writing your ANOVA approach, you want to test your treatment. So please write your null and alternative hypothesis. Dia kadang-kadang dia tak mention write the null and alternative hypothesis, but actually when you conduct your testing for ANOVA, you need to write what is your null, what is your alternative. Okay. So now you want to compute your sum square total. Okay, sum square total. So you write down your formula, double summation yij square minus your grand total divided by your capital N. So now you have yij squared. You already found 125084. Okay. Minus your grand total 1712. So divide by 24 observation. Okay. So try to compute that one. Sum square treatment. So we have yi that square over ni over capital N. Okay. So we will have okay. So sum square treatment, you have total for first treatment square divided by number of your observations. So now your number of observation is unequal for each sample size. So okay, total dia sama lah. 9 plus 8 plus 7. Okay. So sum square total. Check So you should get 2961.33. Ambil 2 decimal point kat sini. Okay, sum square treatment boleh cuba computekan sum square treatment dapat berapa? Okay, 665.9. Okay, sum square treatment 665.90 ataupun ayolah. Okay. So now you compute your sum square error. So sum square error, you have sum square total. So minus your sum square treatment. Okay, so you have sum square total is just 2961.33 minus 665.90. Apa tu? Okay, once you get your value, you present in ANOVA table. Okay, 2295.43. Okay, so we already have three values, sum square total, sum square treatment, and also sum square error. Okay, present in ANOVA table. Okay. Okay. You have source of variation. Okay, then you have sum of square, and then you have a degree of freedom, mean square, and then you have your F. Okay, so first you have treatment. Okay, ini jangan tertukar treatment, error, and then you have total. Okay, so sum square treatment, we have 665.9. Okay, sum square error 2295.43. Okay, so sum square total. Okay, so now degree of freedom. So we have treatment, your K is equals to 3. So treatment, you have K minus 1, so 3 minus 1. So this one, N minus K. So your N is 24. So 24 minus 3, which is 21. So the last one is N minus 1. Okay. So next you compute your mean square. So mean square is just sum square divided by degree of freedom. Okay, so you have 665.9 divided by 2. So 332.95. And then you have 2295.43 divided by 21. 331 lah ya. 31. Okay, so last we compute your F value. Okay, so you get 3.046 lah ya. 3.046. So that is your F calculated. Okay, F calculated. Okay, now. So since this one is your ANOVA approach, so we only reject our null hypothesis, reject H naught, when you have your F calculated, okay, is greater than F alpha. So you want to test at alpha 0.05. Your degree of freedom is 221. Okay, find from your stats table. Apa dia punya value dia? Dapat kan? Alpha 0.05, degree of freedom, V1 2, V2 is 21. Okay, dapatkan dia punya value dia berapa tu? Okay, bagi saya value apa dia punya F critical dia? What is the critical value for F test? Okay, 3.49. Okay. So again, you compare. So our F calculated is 3.046, which is less than. So since our F calculated, Kalau dalam table tak ada itu. Ambil yang paling hampir. Okay, kalau tak ada 21, ada apa? 22. 20 ke? Kalau ada 20, ambil 2 and 20. Okay, sebab kat sini kita tak ajar interpolation ya. Kita ambil nearest value. So, since your F calculated is 3.046, which is less than, okay, less than F 0.05 to 21, which is 3.49. Okay, so fail to reject is not. Okay, so fail to reject is not. So that's mean our conclusion, there is no significant difference between the three different approach of learning English. Ataupun kamu boleh jawab lah. The mean English score of all fresh graduate experience with each of the learning approach is the same. Okay, there is evidence. Okay, since we have failed to reject not, so that's mean mu beta, mu gamma, and mu delta is the same thing. Okay, kamu buatkan dia punya conclusion eh. So that's mean there is evidence to indicate that the mean English score of all fresh graduate experience with each of these learning approach is the same.